students, you are welcome back to Dr. OJ tutorial class. In this video, we shall discuss differentiation of inverse function. Stay blessed as you watch. Now, let y be f of x, where x is g of y. You know, that is, we have a function y equals to f of x, but our x here is g of y. So which invariably means that y is f over g of y. Okay? Now, if we differentiate with respect to y here, as we have learned in our previous differentiation of composite function, or implicit function, this will be dy of y, dy, because we are differentiating y, is equal to d of dx of f of, because this function is f of x. This is like f of x multiplied by this, okay? Dot. Now, this is a composite function, f of x, but x is g of x. So f of differential value of f of x multiplied by our x is what? G of y. So that will be dx dy. Dx dy. I hope you understand what I've just done there. It's a composite function, f of x. If I wanted to differentiate this, I will have f prime of x. And f prime of x is what? Is what I've done, is what I've written here, d of dx of f of x. Then multiply by the variable dx of dy, because our x is another function of g of y. Okay? Now, which implies this one will be what? This one is 1, because when dy is what? 1 is equal to, this is d of x of f of x, that is what? Dy dx multiplied by, why did I write y here? Y is f of x. You can replace f of x by y. I hope you understand. Times dx dy. Yes, if I have this, to get the y dx here, I can just divide this by 1. Hence, dy dx will be 1 over dx dy. So the same thing, if I want to get the dx dy to be 1 over this, dx dy will be 1 over dy dx. So that is just the illustration. I repeat again, y is a function of f of x where x is g of y. Okay, now you replace x by g of y here. But take note, if you are multiplying, if you want to differentiate y with respect to x and x with respect to y, the combination of this function itself is f of g of y. This is f of x, but x has been replaced by g of y. So we have dy, actually it's supposed to be dy dx, but this is a function of y. So dy dy equals to, now f of x, now d of f of x dx, because it has a composition of it has a variable of x. That's why d of f of x dx multiplied by, what is here is x equals to y, so it will be dx dy. I hope you understand. Fine. So, and this is 1. Okay, y, if you differentiate y is 1, then equal to, now d of f of x over dx, that's f of x is y, you replace it, then multiply by dx dy. So now to make dy dx formula, divide both sides by dx dy. That's it. Dy dx will be 1 over this, or dx dy will be, you understand that? If you multiply both, you have 1, which is correct. Now let's look at examples to buttress this explanation. Let's look at examples to buttress this explanation. Very simple. Okay. Example 1. Example 1. Find dy dx. Find dy dx. If y equals to arc sine x. Find the y dx if y equals to arc sine. That is, y equals to sine inverse of x. That's the meaning of arc sine. Now, if that happens, this implies x equals to sine y. That's the meaning of this statement. Yes. So, and now, remember in our previous trigonometry, we are meant to know that, recall, sine square y plus cos square y is equals to 1. Yes, we want to find an equivalent of sine y. So, sine square y will be 1 minus cos square y. Fine. So this will be what? This will be sine square, this is sine y now, equals to square root of 1 minus cos square y. Are we following? Okay, now that invariably, okay, we don't have cos square y here, but we have sine y. So that means it will be better we make cos square y the subject of formula. So now, from here, making cos square y the subject of formula, we have okay, cos square y is equal to 1 minus sine y. Yes, beautiful. So that you can easily substitute for s equals to sine y. So the square root of this one got cos y will now be square root of 1 minus sine square y. Beautiful. Yes, because already we know what s is replacing. Then we have what? That implies cos y equals to square root of 1 minus x squared. Yes. Cos y equals to square root of 1 minus x squared. I hope you understand how we go that, because y is equals to x equals to sine y. So in that case, cos y equals to, and from the given problem, from x equals to sine y, from x equals to sine y, dy dx can be obtained here. So we have dx dy equals to cos y, dx dy. Okay, if dx dy equals to cos y, then you can say dy dx is 1 over cos y. Of course, inverse of this, which implies that dy dx will be 1 all over, and what is our cos y? Square root of 1 minus x squared. Yes, that is it. Square root of 1 minus x squared. That is it. So let's solve more examples. Let's solve more examples. Another one. Let's solve another one. Example 2. Find dy dx if y is equal to arc cos x. This is another one. So this means y equals to cos inverse of x. That's meaning of r cos inverse. So from here we have x equals to cos y. X equals to cos y. So we can differentiate this directly by saying dx dy is equals to minus sine y. Yes. You can differentiate that directly by saying that, okay? Differentiate that directly by saying that that equals to that. All right? Now, which means that dy dx will be equals to minus 1 over sine y. Yes. If you find the inverse of this, 1 over this will be dy dx. Okay? Now, how do we get sine y? We recall that. Recall. Sine square y plus cos square y is equals to 1. Yes. How do you find the equivalent of which of these are we going to find is equivalent now? We need something like sine y. Okay. That means we make sine y solve a formula. Sine square y will be 1 minus cos square y. Yes. Because we want to replace this value. Okay. So that will be sine y, the square root of 1 minus cos square y. Because find the square root of both sides. Alright. So sine y will be equal to square root of. Originally we have x to be cos y. So that will be 1 minus. And this cos square y, square of this, x square. I hope you understand. Fine. So eventually from dy dx is equal to minus 1 over sine y, we have what do we have now? We have what? We have dy dx is minus 1 over sine y is now what? 1 minus x squared. So that solves the problem. Let's look at another question. Let's look at another question still under differentiation of inverse function. Okay. Evaluate. Okay. Example. Let's call this example 3. Find dx of arc sine of 1 minus x squared all over 1 plus x squared. Find that of that. Okay? Alright. How do we go about this? Now, we want to find that we are trying to find the derivative of sine inverse of 1 minus x squared over. Now, the one that is rational, let's use something to represent it. Let u, we might decide to use something else so that we don't run into trouble. Look, let's use a variable a. Yes, is equals to 1 minus x squared all over 1 plus x squared. You know the reason why we are using a now. Yes. Now, we first of all must recognize that a is a rational value there. So, and it pertains that we need to get the equivalent of this, because what we have to find, this one means y is equal to arc sine 1 minus x squared all over 1 plus x squared. So we are trying to find the y dx if this is equals to that. I hope you understand. If this is equals to that, this expression, we want to find d of the x of this. So if now y equals to this, and we said a is equals to this implies that y is equals to arc sine a. So a will be equals to sine y. I hope you understand what I did there. Don't get confused. This is the question. I can also say, okay, this implies that we want to find the differential value of this. Let's assume that this function is y equals to this. Okay, we want to differentiate. What we want to differentiate is y equals to sine inverse of this. So that's what you are asked to find. To differentiate y equals to sine inverse of this, I can replace the whole value here with y and write this. Okay, now, and I say let a equals to this. So which means I have y equals to sine inverse of a. Okay, so a can be sine y. So we have the a dy equals to cos y. I hope you understand that. The a dy equals to cos y. Now ordinarily, for me to get the y dx, I will need something, okay? I will need something here. And what will I need? Fine. I've gotten the a dx, the y. So I will need something like dy dx to get, because if I multiply this by dy dA now, it will be 1. But if I have dy dx, it will be dA dx. So that means I need dA dx. Okay? Fine. Let me now differentiate dA dx. You will get it. Just follow the procedure. I want to differentiate dA dx. Now to find dA dx, we use quotient rule that we have learned before, because it's a rational function. So let's differentiate. Let's differentiate that. And I don't want to clean everything so that I will not forget. I will not forget them when I need them. So let me just leave that one. I have my a is now what? 1 minus x squared all the way up. Is that, I think I've cleaned this too. Is that a equals to, beautiful. So now I want to differentiate the a with respect to x using quotient rule. So the numerator will be u, this will be v. So the a, the x will be, remember very well in v du dx minus, that's 1 plus x squared. Du dx is minus 2x, then minus u dv 1 minus x squared. dv dx is 2x all over 1 plus x squared squared. Yes, that is what I've just done there is now using what? V du dx minus u dv dx all over v squared. That's the quotient rule. That's what I have used here to get this. And my v is this. I write it. I differentiate my u into minus 2u at 2x, then minus my u is 1 minus x squared. I differentiate my dv, which is, if I differentiate, this is 0 plus 2x all over my v. I said my v is 1 plus x squared, and v squared, that's 1 plus x squared or squared. So the a, the x will now be, when I expand this, I have minus 2x minus 2x cubed, then minus 2x plus 2x cubed all over. Yes, these 2x comes here, but minus 2x times this minus 2x. The minus 2x times minus 2x squared, that's it, plus 2x cubed all over 1 plus x squared all squared. I hope we are following. There is no magic here at all. So what next? The a, the x will now be, this will cancel this. I will have what? Minus 4x all over 1 plus x squared all squared. Yes, minus 4x all over 1 plus x squared all squared. Beautiful. Now, if I want to get from here, my dy dA is so recall, you know, the dA dy is cos y. From dA dy equals to cos y. Dy dA will be 1 over cos y. I hope we are following. Okay. That's the inverse. Therefore, thus multiplying dA dx by dA dx times dy dA will give us, let's check, dy dx. Wow, will give us dy dx. So we now multiply. We know we have gotten dA dx to be this. We have gotten dy dA to be this. Okay, we've gotten that to be that. Let's try to bring them together. Let's try to now what dy dx will now be equal to dA dx minus 4x all over 1 plus x squared, then multiply by 1 all over cos y. 1 all over cos y. Yes, because the y dA is 1 cos y. So what do we have there? Good. Now let's now try to find the equivalence of cos y. Recall, cos square y plus sine square y is equals to 1. So cos square y is equals to 1 minus sine square y. So cos y will be square root of 1 minus sine square y. I hope you are following. Beautiful. So which means that cos y will be square root of 1 minus, and what is our sine y? From our question, what do we have as a sine y? Our sine y is equals to a. Yes, a equals to sine y. Remember, a equals to sine y. That's what we have in our. So a is equals to sine y, and our a is what? Is 1 plus. I think that's what we get. A equals to sine y. Our a is equals to 1. So this one can be minus a squared, because yes, if you check again from the beginning, you see that our a is sine y. So sine square y, that is a is sine y, square of a is sine square y. Okay, so and note a is equals to 1 minus s squared. I think 1 plus, I don't know, let me check. I think that is our a. Yes, so that implies that we have square root of 1 minus a squared, 1 minus s squared all over 1 plus x squared all squared. Yes, so we can decide to open up the bracket. Yes, I think it will be proper here. This is the same thing as writing square root of 1 minus s squared, so that you will not be confused, all over 1 plus x squared. Yes, so we can find the LCM. Take your time, you get it. Find the LCM. You have the LCM is 1 plus x squared all squared of the one in the square root. So all over, this one is like 1 over 1. So this will have, you have what? 1 plus x squared all squared. Then minus this one. When this one cancels, is 1 times all of this. 1 minus x squared. Yes, that's what we are going to get. So now if you look at this closely, you see that this has given us difference of 2 squares. Yes, what do you have in the numerator? Now recall, Recall, a square minus b square is a minus b, a plus b. Yes, so we can evaluate this as 1 plus s squared minus 1 minus s squared into brackets 1 plus s squared plus 1 minus s squared. I hope you understand what I did there. I assume this one is my a, this one is my b. So I'm from difference of two squares, a squared minus b squared is a minus b multiplied by a plus b. So if this is a minus b, that's why I say a 1 plus s squared minus my b here multiplied by then a again 1 plus s squared plus my b here 1 minus s squared. I hope you understand. Fine. So this will be 1 plus s squared minus 1 plus s squared multiplied by this will cancel this will be 2. So this will cancel this will be 2x squared multiplied by 2. That's 4x squared. Beautiful. So that means that it's long but it's simple. Take your time, you'll get it. That means this one is now what? Square root what? 4x squared all over 1 plus x squared squared. So and this one will be what? 2x all over 1 plus because when you are finding square root of both sides, x squared. And recall, how did we get there? We got there through we said dy dx. We've almost forgotten how we got there. Okay. We said dy dx is equal to, what did we say there? We said dy dx equals to du dA dx times I think dy dA. Is that what we did? Yes, dy dA. Dy dA. So, and which implies that our dA dx was 1 over, I think we have our dA dx was minus, so therefore this will be minus 4x all over, that's what we got before, 1 plus x squared all squared multiplied by dy dA is 1 over cos x and cos y, and which has given us what? 1 over cos y, and that has given us cos y now has given us what? So we have gotten 2x. So this is what we get as cos y. So 1 over cos y now would be, we shouldn't be confused. It's because we didn't take note of this here. The board could not accommodate the whole of this. It seems as if we are forgetting what. So now, our cos y was this. Yes. So 1 over cos y will now be this, which means dy dx will now be equals to minus 4x all over 1 plus x squared all squared multiplied by, this is cos y. If you check the production, the video. So the inverse of it is what? 1 plus x squared all over 2x. So this one will cancel 1 out of this. This one will cancel this, and we have 2 here. So dy dx will now be minus 2 all over 1 plus x squared. So that's the solution. Yes, that's the solution. So don't be confused here. We have gotten this before, but we have cleaned it up. So 1 over cos y multiplied by this dy dx, and these are cos y. If you check again, so the inverse of cos y is 1 plus x squared over 2x, which is, by the time multiply it by the inverse of this, you get this. It's very simple and straightforward. So with this, we have come to the end of differentiation of inverse function. Don't forget to click on the notification bell so that each time I upload a video, you'll be duly informed. Stay blessed.